7.3, proving that a quadrilateral is a parallelogram. Now, in 7.2, you were told, hey, this is a parallelogram, therefore, these things are true. So, for example, the opposite sides theorem, this is a parallelogram, so we know the opposite sides are congruent. In 7.3, we're going to give you, so for example, the opposite sides converse, meaning we're going the other direction. So we're going to say, well, if the opposite sides are congruent, then we can conclude, or we can prove from that it is a parallelogram. So we're going the other direction. So the opposite sides converse says if opposite sides are congruent, then we can conclude that ABCD is a parallelogram. That's the opposite sides converse. So moving on, opposite angles converse. So if it's a parallelogram, then we know the opposite angles are congruent. But let's just say we have a quadrilateral and we know the opposite angles are congruent, then we can conclude that that quadrilateral is a parallelogram. So if opposite angles are congruent, then ABCD is a parallelogram. Opposite sides parallel and congruent theorem is if one set, okay, just one set of opposite sides are both congruent and parallel. Okay, so take a look at the picture. Just one set has to be both the same length and parallel to each other. Then ABCD is a parallelogram. And then we have the diagonals converse. So if the diagonals bisect each other, which means cut each other in half, then we can conclude that ABCD is a parallelogram. So on the next page, we have 5 ways that you can prove a quadrilateral is specifically a parallelogram. Number 1, you can show that both pairs of opposite sides are parallel. That is the definition of a parallelogram. It has opposite sides parallel. Number 2, show that both pairs of opposite sides are congruent. Number 3, show that both pairs of opposite sides are congruent, angles. This one was sides, this one's angles. Number 4, show that one pair of opposite sides are congruent and parallel. And then number 5, show that the diagonals bisect each other. Those are the 5 ways you can prove that a quadrilateral is a parallelogram. So example 1, we're going to prove the parallelogram opposite sides converse. And then once we prove it, then you can just use it in a proof moving forward. So we are given that AB is congruent to CD, and we're given that BC is congruent to DA. And given that information, we need to prove that this is a parallelogram. And you can't use the opposite sides converse in the proof. That's what we're trying to prove. So we're going to set it up. Work. Reasons. Number 1, AB is congruent to CD, and BC is congruent to DA. And that is our given. Now, in order to try to prove that this is a parallelogram, I'm going to try to use on the previous slide, number 1, the definition of a parallelogram, which means somehow I'm going to try to prove that BC is parallel to AD. Right now I don't know that, I only know that they're congruent. And I'm going to try to prove that AB is parallel to DC. The way I'm going to try to prove that is by alternate interior angles. Because remember, if alternate interior angles are congruent, parallel lines cut by a transversal, then I know that I have parallel lines. So the first thing I'm going to do is I'm going to consider this triangle up here, and I'm going to consider this triangle down here. And I'm going to try to prove that those triangles are congruent. I currently know that this side and this side are congruent, and this side and this side are congruent. The last side I need, number 2, is that AC is congruent to AC. And that is the reflexive property. Now, once I know that, I have side, 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 which tells me the triangles are congruent. So number 3, I'm going to say triangle ABC is congruent. So ABC is congruent to CDA. And that is because of side, side, side. Now, once I know triangles are congruent, then I know all their pieces are congruent. The sides are congruent, the angles are congruent, everything's congruent. So I'm first going to look at this little angle tucked in here near A, and this little angle tucked in here near C. And I'm going to say that angle BAC, that's B to A to C. Notice you can't say angle A, because angle A also kind of includes this little piece down here. So you have to give me the 3 letters. BAC is congruent to angle DCA, comma, and then I'm also going to point out this guy and this guy. So that's going to be angle CAD is congruent to angle ACB. And the reason I can say that is because corresponding parts of congruent triangles are congruent. Now from there, step 5, well, if these angles are congruent, those are alternate interior angles. Well, if alternate interior angles are congruent, cut by a transversal, then I know that the 2 lines that they're touching must be parallel. So now I can say that BC is parallel to AD, and I can also say that BA is parallel to CD. And that is because of the alternate interior angles converse. Now, once I know that the lines are parallel, I know that opposite lines are parallel, well, then I know that this thing is a parallelogram. So number 6, then A, B, C, D is a parallelogram, and that is by the definition of a parallelogram. If both sets of opposite sides are parallel, then I know I'm working with a parallelogram.